Hello everyone, welcome to this session. Today we will look at some example of linear regression and logistic regression. So let's begin. Let's say we are studying the housing market and our task is to predict the price of the house given its size. So for that we have a small house pricing 60 lakhs and a big house whose price is 1.4 crore. And we have to estimate the size of the medium size house. How do we do it? Well, there's a quiz. You have to estimate the price of this house, whether it will be 60 lakh, 1.5 crore or 1 crore. Pause for a moment and think about it. So in order to do this, we will put them in the grid where the x-axis represents the size of the house in feet and y-axis represents the price of the house. And to help us out, we have collected some previous data, which is in the form of this blue dot. This blue dot shows the other house we have looked at and recorded their price with respect to their size. Here we can see that the small house price is 60 lakhs and big house price is 1.4 crore. And we see that this point form a line and we can draw a line that better fits this data. So by this line, we can predict the size of the medium size house. So the best guess or the price is this point over here, which correspond to 1 crore. And this method is known as linear regression. And now you might be thinking how to find the best line that fits this data. Let's try with a small example. Here is one point and you have to find the line that perfectly fits this data. We'll start drawing a random line and we will see how bad the line is. In order to see that how bad the line is, we will calculate the error. And to find the error, we are going to see the length of the distance between the line to these 3 points. And we can see the error of this line is the sum of this length. And now we will move this line around to see if we can reduce the error. So let's say we will move in this direction. And we calculate the error again. And now it is given by the yellow line. And we realize the error is increased. This is not good. Let's move the line in another direction and calculate the error again. And we see that the error is small. And if we continue doing this process several times, we will decrease the error and we will arrive to the good solution. It is a general procedure to minimize the error. So we will go to another example now. Let's say we are an admission officer in college and we are trying to find out which student to admit. For this, we will look at the two pieces of information. First is test score of the entrance exam and grades from the school. For example, we have a student 1 who got 9 in test and 8 in grades. And that student got accepted. We have another student who scored 3 in test and 4 in grades. And that student was not accepted. And now we have a new student who scored 7 in test and 6 in grade. And the question is, we accept him or not? So to decide this, we'll just first put them on the grid, where x-axis represent the test and y-axis represent the grades. And here we looked at the student 1 would lie over here, whose coordinate will be 9, 8, and student 2 lie over here and the coordinate is 3 and 4. In order to find the student 3 would be accepted or not, we will look at the previous data. And the previous data look like this. Previous data, green point here represent the student where they previously accepted, and red point represent the student where rejected. So now there is a quiz. What do you think the student 3 will be accepted or not? Pause for a moment and think about it. To answer this question, let's look closely at the data. We find that the green and red point nicely separated by a line. Here is the line. We can see that most of the point above line is green and most of the point below line is red, with some exception. And that line is going to be our model. And now when the new student come, we check their score and plot them in this graph. If the point is above the line, we predict that the student will be accepted. And if they are below the line, we say that the student will be rejected. Here, since the student 3 lie above the line, that is 7 and 6 coordinate, so we see that he will be accepted. And this method is known as logistic regression. Now the question is, how do we find the line that best fit the data? So let's look at this example. Here, there are green points and red points. And now, how we will separate the green point with the red points? So, for that, we will draw a random line and we will label the region over the line as green and the region below the line is red. So, just like a linear regression, we will find how bad the line is and we will find number of errors, that is number of misclassified points. This line misclassified 2 points. One is red and another is green. So we say that it has 2 errors. And now we will move the line around to minimize the number of errors. So we move the line in this direction. And we see 1 point is misclassified, bringing down the number of errors to 1. And we again move the line and we see the point are we see that the point are correctly classified, bringing down the number of error to 0. So the goal of this process is to find the line that perfectly fits the data by minimizing the error function. That's all for this video. I will see you in the next class. Thanks for watching this video.